Good day, viewers and the class. Welcome to Easy Learning Tutorial class. What I have for you today is question that said, with aid of a diagram, explain refraction through several parallel side media. We should explain the word refraction using what? Through what? Several what? Parallel side media. The second question said, show that a refraction of what? Air to water sine R1 is equals to refraction of air to glass sine R2. The third question said, a ray of light is incidented in a water at an angle of 30 degrees on a water glass boundary, a water glass plane surface. Calculate the angle of refraction in the glass. He said, a ray of light is incidented in water at angle of 30 on a water glass plane surface. Calculate the angle of refraction in the glass. And they give me A to glass and A to water. Let's go to solution. Before we go into this solution, while we are here, remember to subscribe to this channel. Subscribe to this channel for subsequent uploading of videos so that you will get a pop message whenever we do that. Subscribe, share to your friend, love this channel and share it to your colleagues. This is a YA question, and this also optics and wave question in YA and university. So pay attention and grab the proper as we explain down. So the first question said, with aid of diagram we should what? Explain refraction. That is the first question. I will draw something. I will draw, and I will draw again. Then here, a ray of light, which is X, is incidented on A. I call this A. And this is my normal. I draw my normal. And I call this median here glass. Glass what? Median. Glass median. And this one what? A median. A median. A median. I think you are following me. A median. Then, this man entering inside the glass, what happened? This is a glass boundary. This line is a glass boundary. Entering into glass, it will what? Reflect close to normal and come to this. This man striking the words here, I have to draw normal again. Look at my normal. You are following? Then this man now striking the word water. This is what we call water. Water median. I call this place water median. This is water median. Striking the water median, this man will refract away a little. It will reflect away a little. Then getting here, striking this face, this is my normal. This is normal. Remember? This is normal. This is normal. Then what will happen? It will what? Run away properly. Are you following? Then this, if I call this incident angle, this R, this one is what? R1. I call this place R1. That's what I name here. R1. Are you getting what I'm saying now? And this place R2. And this place R3. Okay? Then here now this boundary is what? A to what? Glass. That means from A entering glass boundary. This place is called water, glass to water, glass to water boundary. That's the boundary between what? This is the glass. I'm in the glass entering water. This place is a glass medium entering water. Here is air entering glass. Then this boundary here is called water to air. And that's the refractive index. Refractive index, you look at this, what I said. I'm already in air, heading to glass. That means this is the refractive index of glass. This man, I'm in the air entering glass. That's the refractive index of glass. I'm in glass entering the what? Water. What I'm looking for now is the what? Refractive index of water. Just like we have seen today. Refractive index of what we are thinking about now is tomorrow. So immediately you are in a medium. You are no more thinking about that medium. What we are thinking about is the next medium where you are entering. That's the refractive index you are looking for. So if I'm not trying to say about tomorrow, I will say if today is Monday, then tomorrow is what I'm looking for, which will be what? Tuesday. So that means I'm looking for a refractive index of tomorrow, not today. I have seen today, which is what? Monday. I'm looking for what? Refractive index of tomorrow. So look at it. I'm already in air, going into what? The glass. I'm looking for what? Refractive index of glass. I'm already in glass, going into what? Water. That means I'm looking for what? Refractive index of what? Water. Here, I'm already in water, going into air. That means I'm looking for refractive index of what? Air. Then now, looking at this, from this now you see that when this man enters glass, he compressed close to the normal. Look at it. He come close to normal. Instead of to move away, he come into close to normal. Then when he entered from glass to water, what happened? He moved away, telling you that glass is more denser than what? Water medium. If glass is more denser than water medium, that's why you see this, he reflects a little, move away from the what? Normal. Look at it, he moved away from the normal, telling you that glass is more what? Denser. While this man, air, what happened? He moved far away from what? Normal, telling you that now he can fly. Just like when you enter into, you are moving now, so I'm moving, and I encounter what? Flood. What will happen to me? My speed will reduce. That means I've moved from my air when there is no flood and enter inside flood, which is another medium. My speed will what? Reduce. So that's what happened here. This man follow from air, enter inside the glass. What happened? The speed reduce. He come close to normal, telling you that what? Glass is more denser than air. That he is free. He is more free than what? In the glass. Then getting inside this glass, from the glass is entering into water. Look at it now. He entered water. What happened? He moved a little faster. Are you getting what I'm saying? That's what we mean by what? Moving away from the normal. But when he was in glass, he come close to normal. Then when he get to what? Water, what happened? He moved away a little far away than what? Glass. You get it right? Then here, what happened? When he emerged out from the air, he emerged out in the air, what happened? He fly out. And that's why you see it move away from the normal. So, characteristics now shows me that what? Glass medium is more denser than water medium from here. So let us see. Let me give you explanation more. And I said I is equals to incident angle on air stroke glass boundary. Glass what? Boundary. Glass boundary. Get me right. Cool down. Then again, R1 is equals to incident angle on glass / water boundary. You get? Then R2 is incident angle on water / air boundary. Understood? Look at this. This man is a refraction angle. Okay? That's all. This is a refraction angle. But this refraction angle is also the incident angle. This man now, which is R1, I label it R1, which is this angle here, is in refraction angle in this first phase. In the second phase, which is here, this man is still what? The incident angle. Why? We said alternate angle are equal. if I write something like this angle is the same thing as this angle. So if this man is R1, this R1 is what goes in here. You get me right? Alternate angle are what? Equal. Look at it. I know. Let me put it here so you to see clear. This angle here is the same thing as angle here. So if this man is my what? R1, this man R1 as well, which he used to enter here, right? Then this man, which is refraction angle in the water, is the incident angle here, the same this what reason, which is alternate angle are equal. This man is what you used. You get me right? So this clear, this is what they asked us on that question said, with the aid of diagram, explain the refraction through several parallel side media. Look at it. I've done that. Let's go to question number B. The question number B says, show that an angle this is this air to water, sine R1 is equals to air to glass, sine R2. That's what they told us to do. You remember, the only thing I know, the refractive index I know in optics is air to glass. That's the only thing we know. Air to glass, which is 1.5, which is exactly 3/2. And water to air to water. Air to water, that means refractive index of water and the refractive index of what? Glass. This means refractive index of glass, refractive index of what? Water. These are only two refractive index we know in a what? Optics. So we now say refractive index of glass is 1.5, which is 3/2. Refractive index of water is what? 4/3, which is approximately 1.3333. Are you getting what I'm saying? Come over here. Let's deal with what? This question number 2. Then here, Anna said, look at here, we said water, air to water. Are you getting what I'm saying? We say what? Air, water to glass. Water to what? Glass. What does this mean? I'm moving from water, entering what? Glass. That means I'm in the what? Water, entering glass. And then this is stated as what? Incident angle in what? Water. This incident angle in water. All over refraction angle in glass. And this can be written as sine of incident angle in water divided by what? Sine of refraction in glass. That means I incidented in water and I refracted in glass. And this man here is the same thing as what? Sine incident in water, sine of incident in water, I in water, this means W water, all over. Sine of refraction in air, divide, this means divide. Sine of what? Incident in glass. Incident in glass. This means incident in what? Glass. All over sine of refraction in what? Air. Are you getting what I'm saying now? This means, can I explain this to you? What does it mean? It means that if I'm in water entering to glass, I will encounter air because there's a space between two of them. If I place this in my hand like this, if I move from this medium entering this second one, there will be air in between there will be air. So if I place now water, place glass, there will be air. So it means that I incidented in water and refract from air before I incidented in glass and refract from what? Air. Before I get another medium. Then now, this is the same thing as sine of incident in water all over sine of what? Refraction in air times sine refraction in air. I think you're saying clear here. All over sine of incident in glass. You follow? You get it right. I said this invert, which multiplication occur. This man will come over, this will come down. Multiplication appear. You get me right? Then now, this thing we'll put over there is the same thing. This incident in water and refraction to what? Air. It's the same thing as water to what? Air. This fraction is simply what? State this way. times the other one is simply stated what? Air to what? Glass. Are you getting what I'm saying? I mean, incident in what? Air. That is incident in that air. Refraction in what? Glass. Mean air to what? Glass. This means water to what? Air. Look at water to air. Air to glass. You get me right? Then back to this. If someone is still confused about this, I've explained this. This getting this from this getting this. Mean that if I keep these two things now, there will be air in between this. If I'm inside this what? This marker. Going inside this paper, before I get to the paper, I will get air. So if I'm in water, before I will get in the glass, I will get air. I will refract in air first. After refracting in air first, I incident again in what? Glass. Then where am I going to do? If I'm going out from glass, I will refract from air before I get another medium. So that's what this man turned to this man turned to this. You get it right. Then now, we move. And this man is equals to but. I think you have gotten our this. But I don't know this. This man is not in my diary. What is in my diary is the refractive index of water and refractive index of glass, which means air to water and air to glass. I have this. I don't have this. But I remember that what? Air, that's air to water, 1 over, okay? Let me clean here so that you can be able to get it here. And I say but. You get me? But. You should pause. That I know that what? 1 over air to water is equals to water to what? Air. Do you know? Yes. That's what we call reversibility of water, reversibility of light. Reversibility of what? Light. That light can what? Reverse. I can enter water from water, enter to air. That's the reversibility of what? Light. That this over this will give me this. Therefore, I can use this to replace this man in this place. I can use this to replace this man in this place. And this will give me 1 all over A to water times A to glass. And that will land me to what? A to glass all over what? Air to water. Understood? This simply means that what? Water to glass, which we are given, is equals to air to glass all over air to water, and is equals to sine of what? Incidence in water all over sine of refraction in glass. Incident in water, refraction in glass. Very beautiful. Very, very beautiful. So this is the only thing I needed to put in my brain. As a YX student, you have seen the proof. This is what I needed to put in my brain. That if I'm giving water to glass, it simply means air to glass over air to water. And the same thing as sine in the incident in water and the refraction in glass. Simple. Then this man also can be applicable, assuming that we are giving glass to water. Are you here? Assuming we are not through from what we are doing, but I want to also get this. Assuming that we are giving glass to water, it simply means from this now we have already derived. It simply means that what? Air to water over what? Air to glass. So if this man is giving to me, for me to get it on what I know, because I told you what we know in what optics and wave is a what? Refractive index of glass and refractive index of water. So any other refractive index we are looking for, we have to resolve, which we are doing now, to be able to suit in refractive index of glass, refractive index of water. So that's what we did now. They are giving us water to glass. I don't have it in my diary. Then we have what? Prove it now. Reverse it to be what? Refractive index of glass over refractive index of water. Clear? Then therefore they are giving me glass to water to find. Is centered at refractive index of water over refractive index of what? Glass. And simply being equals to sine of incident in glass now all over refraction in what? Water. Refraction in what? Water. Are you getting what I'm saying? So if this is given to me, look what this is given to me, look at it. So now back to what we are proving. Can we come over here? I can claim this. I think you have noted this. You have noted this. Note them. Take the note of this. So I'm claiming it. So I will go ahead for the completion of the question. So since you have noted that, let's complete the question over here. We are going to this to say that this question, this, look at what we do. This man now, it simply means that that this is equals to this. Therefore, I cannot say that A to what? Glass over A to water is equals to sine of R1 over sine R2. R1 represents incident in water, R2 represents refraction in what? Glass. And cross multiplication, if we cross multiply, I will have that what? A to water sine refraction in 1 equals to A to glass sine refraction in 2. And that's what they say we should prove. We have proved that. Then now, let's go to the third question. Look at what they say we should prove. We have proved that. Then let's go to the third question. The third question is telling me a ray of light is incidented in water. That means at 30 degrees. On water glass boundary, that's water glass boundary. That is entering into what? Glass. Calculate the refractive index in glass. Come on. Can we come over here? I can claim this. Have you noted this? Note them, note them, note them fast. Let me claim this. I can claim this right now. Remember to what? Subscribe. Subscription on this channel is free. Subscribe for your benefit. It's free. Then now, let's go to question number C. Come over here. What they asked me, the what? Refractive index in a what? Glass. I will use this formula right now. Look at the formula. You said water to glass. That's what you head into. And we have already proved it to the what? Air to what? Glass. All over what? Air to what? Water. And is equals to sine of incidence in water over sine of what? Refraction in glass. Then I can now say this man is A to glass all over A to what? Water. And is equals to sine of what? Incidence in water all over sine of refraction in glass. Are you get what I'm saying? What they ask me, refraction in glass, cross multiplication, I will have that refraction in glass, making it subject of formula. I will have that what? A to water, and the sine of what? Incident in water over what? A to glass, cross multiplication, and making this subject of formula. That's what we have. Where, what do they give me? Sine of what? RG. This man, A to water is given to me as 1.33 times sine of 30 all over water. A to glass. A to glass is what? 1.5. Can we press it? Fast. Can somebody press it for us fast? I cannot say that sine, this gives us what? 1.3 times sine what? 0.5 all over 1.5. Then I can say R is equals to sine inverse of, when you press this, it will give you 0.4433. When you press that, it will give you 0.4433. Then when you do that, that will give you R refracting in a glass will give you approximately 26.31 degree. You see what we did here? Multiply them and divide with your calculator, give you this. Find the inverse of this, that will give you this. And that's what we have for you today. This man is giving to me angle, incident angle in glass, in water, is given to me as 30. Look at the incident, incidented in water at what? 30 degree. That's the incident in water is what? At 30 degree. Then now, sine 30 is 0.5. Are you getting what I'm saying? Sine 30 is 0.5 times 6, which is water, refractive index of water, which is 1.33, over refractive index of glass, which is 1.5. When you divide them, it gives you this. And when you divide, this will give you 0.4433. Then you will now say the refractive index of what? Glass. Refractive index, refraction in glass become what? Sine inverse, because this is equal to this. You now find sine inverse of this, and that will give you this. I think we are clear to this. I'm making subject of formula right now here. You know how to make subject of formula cross multiplication. I get what I'm saying? And substitute the value. I know refractive index of water, refractive index of glass is given to me. Refractive index of water, refractive index of glass. Are you watching ever? We put it here. Then incidence in water, which gave me as 30. I put it here, find the sign and multiply together. I will have this. Are you get what I'm saying? And this will give me sine inverse of this, and that land me to this. And that's the answer of what they asked me on the second question. Remember to subscribe in this channel. Any questions, you can comment. Your comment is necessary. Comment so that we can know where we are doing you good and where you are confused. So let the comments be coming up. Share it to your friends. Subscribe to this channel. It's free. Subscription is free. Share it. Love the channel. Love the channel. If you are about to write WAEC, love this channel. And love this channel because everything we're going to do in this channel is all about here question and answer in WAEC question. So love it, comment, share to your friend, inform your friend all about this particular channel so that they will help, they will also benefit as you are benefited in this channel. There's another things we are going to upload which will be of your practical. Remember, by the time you subscribe, every of our posts will reach you. Thank you for watching this video. See you in the next video.